Okay, so we're going to be solving systems of linear systems by using what's called combinations. It's going to be just actually adding together two different linear systems and getting one variable to cancel out. So first thing we want to do is arrange the equations with like terms in columns. So making sure that we have the x and the y in the same column and the constant terms on the other side of the equal sign, just like the example on the bottom. We skipped part 2 because the second step is going to be in part 2 that we're doing tomorrow. So the third thing is we're going to add the equations together. So add my x's, add my y's, add my constant terms. And when we do this today, magically this will eliminate one of the variables. And then we can solve for the remaining variable. Last thing is then once you find out what one of your variables is equal to, plug it back into the top equation, and that will be how we find out what the other variable is, and then check your answer. So when I'm doing this, these ones are already arranged so that the like terms are in columns. So I do 4x plus 2x, that gives me 6x. 3y plus negative 3y, those cancel each other out and give me 0, so I don't have to write anything. And then 16 plus 8 gives me 24. So I divide both sides by 6. So I have x is equal to 4. And then since I want to figure out what y is, I'm going to plug this back into the top equation for x. So it'll be 4 times 4 plus 3y is equal to 16. Oops, there we go. So 16 plus 3y is equal to 16, minus 16 to both sides. So 3y is equal to 0, and then divide both sides by 3, and so y is equal to 0. So the x is equal to 4, y is equal to 0, and I always want to display that as the ordered pair 4, 0. And I could double check this back into both of my equations. So if I plug it into the top, I get 4 times 4, which is 16, and 3 times 0, which is 0. So 16 plus 0 equals 16, that works. Plug it into the bottom, 4 times 2 gives me 8, 3 times 0 gives me 0, so 8 minus 0 is equal to 0, that's true also. Oops. This example over here on the left, I don't have my x's and y's in the same column, so what I have to do before is I have to move my x over to the same sides. Oops. So I'm going to minus 2x to both sides. So it disappears from the right-hand side and then comes over to the left-hand side. And again, I want my x before my y, so I go negative 2x plus a positive 2x, or y, equals negative 2. Then I rewrite the bottom equation. 2x plus 3y equals 12. Now my equations have x's in the same column, y's in the same column, and constant terms. Negative 2x plus 2x gives me 0. 2y plus 3y gives me 5y. Negative 2 plus 12 gives me 10. Divide both sides by 5. So y is equal to 2. Then to find out what x is, I can plug it back into my original equation. Doesn't matter which one, I'm just going to do the bottom one. So you get 2x plus 3 times 2 is equal to 12. So 2x plus 6 is equal to 12. Minus 6 minus 6. 2x is equal to 6. Divide both sides by 2. So x is equal to 3. Y is equal to 2, so my ordered pair is 3, 2. In this word problem, I've got Mr. Metzger's first period algebra class begins with 39 students in it and decreases by 2 students per week. My fourth period class begins the year with 3 students and increases by 2 students per week. So I want to find out when my classes are going to be equal. So I can write an equation for my first period and my fourth period. So for my first period, it started with 39. And it decreases by 2 students per week. So I can write it as 39 minus 2x equals y. My fourth period started with 3, added 2 per week. So 3 plus 2x equals y. Then I can put these guys on top of each other. So 3 plus 2x equals y. And add my columns again. So you get 42 That gives me 0 equals 2y, and I can divide both sides by 2. So 21 is equal to y. That's going to be 21 students. So then to find out how long it takes, I'm going to plug that in for y. So you get 3 plus 2x equals 21, minus 3 and divide by 2. That's it.